2018 question number 5, part 1. So we can see just by glancing at it that it's going to be polar coordinates. We want to think about all our formulas for polar coordinates. The first one, part A, is pretty straightforward. It says we have a graph that is inside r equals 4, outside r equals 3 plus 2 cosine theta. So we see that picture here. Write an expression involving an integral for the area of r. And they were nice enough up here to tell us that the curves intersect at theta equals pi over 3 and 5 pi over 3. So otherwise we might have to figure that out somehow. Probably they gave us this because it's a non-calculator question. So if this were a calculator active question, you might have to, make a graph and find where those intersection points are to know where we begin and end. So the only thing you really have to know to do this first part is that the area is 1/2 the integral from a to b of the outside radius squared minus the inside radius squared d theta. You do have to know which one's outside and which one's inside. So like outside and inside means which one's closer to the origin. So the outside function is farthest from the origin. So this is our outside function out here. And we can see that that function is a circle. It's constant. So that must be the r equals 4, 1. So the r equals 4 is going outside, and the other function is going to be the inside function. So it's that r equals 4 that has to come first. So we have to write a equals 1/2 integral from a to b of our outside function, which is 4 squared, minus our inside function, which is 3 plus 2 cosine theta squared d theta. And of course, what I should have put right away for a and b is the limits, pi over 3 and 5 pi over 3. So you should do that right away. I'll go ahead and just add it in a separate step since I forgot. It's no big deal. We'll just put it in, pi over 3 to 5 pi over 3 of 4 squared minus 3 plus 2 cosine theta squared d theta. So all they've asked us to do is write an expression involving the integral. They don't ask us to evaluate it, so we don't have to. I mean, you could. Actually, this would involve a cosine squared theta, which is one of the topics that I'm holding for the end of the year after we do the AP exam. So it's kind of interesting. As far as your AP curriculum is concerned, you wouldn't know how to do this integral without a calculator. So again, it's a no calculator section. That's why they didn't have you evaluate this integral. There's also a sort of a trick to that, because like normally if you're confused about the outside and the inside function, you can just do the integral, and then if your area comes out negative, you can switch the two functions. So we don't have that option here. So because we're not evaluating the interval, we have to be more confident about which function's going first. So think about which function is farthest from the origin. That's your outside function. Which function is closest to the origin? That's your inside function, and it's going to go outside minus the inside. So you really think we need the area to be positive. So it's going to be the larger number minus the smaller number. The larger value of r is the one farthest from the origin.